Today we are talking about all three methods that we have currently for finding roots. The third one we will talk about today. So the first one we talked about in class was factoring. Okay. The reason that we like to use the method of factoring, it's probably one of the quickest. It's a little bit quicker than quadratic formula, plugging all that in, trying to figure out if a square root works or doesn't work. This one gives me nice answers when it's possible. Okay? Now, contrarily to that, not reason to not use it, some don't factor, right? So we have more methods than factoring because some of them won't factor for us. We got to have other methods for that. So let's review quick procedure for that. When we're factoring, what's step one? Before we do that, we move everything to one side, most likely the left. Move everything to one side. I'm going to put in parentheses here. It has to equal 0. Step 2, we always do what? Check for a GCF. Step 3 is to finish factoring however you need to. The box, difference of perfect squares, one of those. Last but not least, what do we do with our factors? Set factors equal to 0 and solve. Okay, so this will be a good reference page for you when you are trying to solve any quadratic. Okay, we find its roots, also known as its zeros, one of these three ways. What's the second method we talked about that we just talked about on our homework again? Quadratic formula. Anyone remember what I said the main reason was we use this one? Always works. Good, Christian. Okay, quadratic formula will always work, no matter what. Okay? There aren't some that don't work with quadratic formula. There aren't like there are that don't factor. Okay? That's your main reason for that. However, the side on that one is that sometimes it takes longer. So that's kind of the offside with that. Yes. All right, quick steps for this. When we're doing quadratic formula, what do? What's the first step? Okay, so same as the factoring one. Move everything to one side. It must equal 0 before this. Step 2 for this is identify your A, B, and C. And I'll just say and plug in to the formula. What do we do after we plug it into the formula? What part do we simplify? Simplify the square root. Okay, and that includes taking out something if you can to simplify. If there's a perfect square that goes into it, or if it is a perfect square itself, you can just square root it. And then our last step is to reduce. And I'm just going to say reduce the numbers outside the square root. We do not reduce the number inside the square root because it doesn't go with the rest. All right. Now our last method that we're talking about today is a very easy method, mainly because we've already done some like this a couple chapters ago. And this one is solving using square roots. So if we are to solve using square roots, here's the reason that we use this. You may only use this when there is no B term. Okay, do you know what I'm saying when I say no B term? When you say ax squared, bx, and c, there is no B term in the middle. In other words, that would have been a 0. Okay? That's the only time you can use square roots to solve. However, it turns into a very quick way to solve if there is no B term. But you got to be able to look at your quadratic and say there's no x by itself. There's an x squared, there's a number, there's no B term. Okay? On this one are steps for this. Step 1 is going to be move C term to the right. Okay, so you're going to leave your ax squared on the left. You're going to move your C to the right. You're going to get rid of A. If there's any number out front of the x squared term, you're going to divide by that or multiply by the reciprocal, depending on what it is. Okay, then we are going to square root both sides. And 4, we are going to simplify, if possible. So those are our 3 methods. We're next chapter going to spend some time learning the last method of solving quadratics, which is graphing. It is probably not the most efficient way of solving, which is why we spend time on the next chapter talking about it by itself. I know, we don't love graphing, but we're going to learn it. Okay? All right, before we review the old methods, I actually want to flip to the back and talk about the square root ones. So I'm going to skip the first examples. We'll come back to them in a minute. All right, if we look down here at the bottom of the back page, notice it says solve using square roots. Now, for today, these say which method to use. It will not always say which method to use. You will have to decide on some of them. Remember I told you on your test, I will probably do something similar to this where I'll give you 2 problems and say solve by factoring. 2 problems solved by quadratic formula. 2 problems solved by square roots. I will also give you a section of some where it just says solve. Pick a method. Okay? Then you have to figure out what method to use. You can try to factor. If it doesn't work, you'd use quadratic formula. If you see that it doesn't have a B term, you can try to use square roots. Okay? So notice on 9 and 10, both of them. Okay, there is no B term in the middle here. No B term in the middle here. These are the only times you can solve using square roots. Okay? The nice thing about solving using square roots is that it's a lot like solving for x, period. Like if there was no x squared there and you're just solving for x, we want to get x by itself, what would we move away in question 9? No, you're right. That's plus 4. It's just like solving for x. We're going to talk about you're going to get 2 because of using square roots, but we'll talk about it. All right, so I add 4 to the other side. You move the c term to the other side. This is the only one that doesn't equal 0 to start with. Then what did we say about that a value out front? We got to get rid of it, just like if we're solving for x. So how do I get rid of the times 3? Divide by 3 both sides. So now I have x squared is equal to 4 over 3. We've picked a very nice one to start with, a fraction. Yay! All right, we do not get decimal answers for this. Well, we have to talk about this, so that's why it's here. Okay, so how do I get rid of a squared on an x? We square root. A square root is the opposite of a squared. So this is the important part for us. If you square root one side, we also square root the other. Okay? Now, when I square root a fraction, the nice thing about this is that you don't have to know what the square root of the fraction 4/3 is. You can handle the top and the bottom separately. Okay? So, here's where we got to pay attention and work carefully on this. I can think about this as the square root of 4 over the square root of 3. The other thing that we have to be cautious with, because Emerson already asked about this, Do you just have one answer for this? When you square root, we put that plus or minus sign that we've seen in the quadratic formula out front, which means you have both a positive and a negative answer to this. Okay? This is because, if you think about it, the square root of 4, we know is what? 2. Well, a square root is defined as what number times itself twice gives me that number inside? Well, 2 times 2 gives me 4. What about negative 2 times negative 2?
Well, it gives you positive.
Also gives me 4. Okay? So that's why we put the plus or minus out front. So if you can square root that number nicely, do it, which you can with that 4. Can I square root 3 nicely? No. So here's where something else comes into play. This has a nice big term down here that I'll write down for you. This is called rationalizing. Rationalizing. I got to think about how to spell that. The denominator. This is a very fancy math term that means I'm not allowed to leave the square root in the bottom. In math, you know how like there's grammar rules in English? In math, it's not considered proper, just like it's not considered to use proper grammar in English with something like that, that you leave a square root in the bottom of a fraction. You're just not allowed to do it. Okay? I don't really know who made up that rule. Someone did. And so we roll with it now, and it's just not considered proper anymore. Okay? So what happens when I have an answer like this is we fix it, which is called rationalizing the denominator. So the nice thing about fixing it is that it's not difficult to fix. I'm trying to get rid of this root 3 in the bottom, right? That means I take and I multiply by the square root of 3 on both the top and the bottom. I'm allowed to do that as long as I do the same thing to the top and the bottom. Pearson, are you paying attention or are you playing with your hair? Okay. So my final answer here, when you have a number like 2 outside a square root and a number like 3 inside a square root, you can't actually multiply those numbers together. They just sit next to each other. On the bottom, when both of them are under a square root, you can multiply them together, which means I get the square root of what? 9. This now becomes a number that I can square root nicely. What is the square root of 9? 3. So my final answer to this question is plus or minus 2 square root of 3 over 3. Now, they're not all that difficult. That is kind of like the longest those get. We're going to practice that a couple more times, though. Okay? Let us, however, try it again with number 10, which is easier than that one. Okay? So let's follow this process again. If I know I'm solving using square roots, what am I going to move in number 10?
64.
The 64. How do I move it? Add it to the other side. I'm again trying to solve for x, so what do I need to get rid of? The 2. So how do I get rid of the 2? Divide by 2. Now, we should be able to tell already this one's not going to be as hard as the last one because I'm not getting what kind of answer over here? A fraction. Okay? So if you don't get a fraction, it's a whole lot easier. If I'm trying to get rid of the x squared and I just want an x as my answer, we just talked about how do I get rid of a squared? I square root both sides. So then we ask ourselves the question, does 32 square root nicely? No, it does not. So we've learned how to do this. We did it with quadratic formula. We think about what goes into 32 that I can square root. 16 and 2. You want to do the biggest one, so we use 16. What is the square root of 16? 4. That goes where? Outside. Where's the 2 go? Inside, and we always put what in front of our answers? Plus or minus, because that tells me I have 2 answers. 2 answers being the positive 4 square root of 2, the negative 4 square root of 2. Okay? Now, what I'd like for you to do is actually take a look at this back of the paper. There's one other one. It falls under the square root directions. No, not the different page, this same page right here. Stay on this page. Okay? There's one other problem here that I could use square roots for.
Number 3.
Number 3. Why?
Because it's
Okay. I could solve number 3 one of two ways. So sometimes you don't have to use the method that they say if it would work for another one. Like if I didn't tell you you had to use factoring on that one, you could use square roots on that one. Okay? That's a really easy one to use square roots for. What would I do? Add 64 to the other side. And then what? How do I get rid of the squared? Square root. And this one's really nice and easy because what do we know about 64? It square roots perfectly, which means my two answers to this are going to be what? Plus or negative 8. Now, I want to just show you factoring on this one. You could have also factored. That is a difference of perfect squares. That means those are the ones that we can draw the parentheses for and say, what is the square root of x squared? X. What is the square root of 64? 8. One is going to be? And one is going to be? Negative. And then in factoring, what do we do with our factors at the end? We set them equal to 0. So if I set both of those equal to 0, what two answers do I get? Positive and negative 8. So if you use a different method for it, you should get the same answer.
Even on number 9?
You cannot do, what?
Even on number 9?
Even on number 9? Yes. You could have used quadratic formula on number 9 and gotten the same answer. Yep. Sometimes, yeah, like some people are looking at 9 and saying, I'd rather use quadratic formula on that. It was kind of nasty. Yeah? Should we do one more like number 9 so that we're not lost when we do them on our homework?
Yes.
Okay. I'm going to make up one for you here.
No, I don't want to do it.
Okay, we're just going to call this number 11 down here. Got to make up a good one here.
Yeah, I don't know.
All right, well, find a blank page and use it. All right, so on this one, let's say we are doing 5x squared plus or minus, 36 is equal to 0. Okay, if I was solving that using square roots, let's go through this process again. What do I move? The minus 36 moves to the other side by doing what? Adding it. What would I then do next? Divide by 5 both sides. So now I have x squared is equal to 36 over 5. How do I get rid of the squared on the x? Square root both sides. And remember, when we square root a fraction, we think about the square root of the top, and we think about the square root of the bottom. And I put what out front? Plus or minus. Don't forget that. All right, so when I simplify this, can I simplify either the top or the bottom?
Yes.
Yes, which one? The top simplifies to 6 over square root of 5 because I can't simplify that. So remember our rule, we cannot leave it that way because that's ugly. How do we get rid of the square root of 5? Multiply by the square root of 5 on top. Multiply by the square root of 5 on bottom. So on top, this is going to give me plus or minus what? Remember, if one's inside, one's outside, what do? They just sit next to each other on top. So 6 square root 5. I cannot multiply those together. They're like unlike terms. One's inside, one's outside. They don't go together. On the bottom, that gives me the square root of what? 25. Which happens to give me what number? 5. Now, what are we noticing about square root of 5 times square root of 5? If I multiply two square roots that are the same, what does it give me as a final answer over here? Just that number. So if you understand square root of 5 times square root of 5, the square roots are going to cancel and it's just going to give me 5. You can skip this middle step in here and just give me the final answer. Just like in number 3, we did square root 3 times square root 3. It ended up as 3 on the bottom. It's always going to work that way if you use two square roots that are the same. So you can skip that middle step if you don't need to do it. Okay? Now, what I would like for you to do at your tables, we have not done the 2 quadratic formulas in the middle of this page, as well as the 1 factoring. Okay? So at the top here, we have 3 problems on this page to do, 4, 5, and 6. We have 2 problems on the previous page with factoring to do with your tables. I'm going to give you the next 12 minutes, and then we're going to check our answers on that. And then I'm going to give you your homework assignment, okay?